Okay, so let's look at this question. This is the more difficult one actually, compared to just now. So let's see the question. The diagram shows a particle of mass 0.6 kg on a plane inclined at 25 degree to the horizontal. Okay, as you can see, 25 degree. The particle is acted on by a force of magnitude P Newton. So this is P Newton, act upwards. Okay, act upwards. So this force is trying to pull up the objects or the particle, pull up the particles against the slope. Directed up the plane parallel to a line of greatest slope. The coefficient of frictions between the particle and the plane is 0.36. So this is the mu. Okay, so this is mu. So let's mark it down. This is mu. Okay, then we move on. Given that particle is in equilibrium, find the sets of possible values of P. Is in equilibrium. So when I say in equilibrium, right? So you have to take it in this way. You have to take it like the force that acts downwards equal to the force that acts upwards. The force that acts perpendicular to the planes is equal to the force that acts in the other side, which is perpendicular to the plane also. Okay, so the forces are equal to each other. So the thing is they want to find the sets of possible values of P. So it is going to be an inequality, the answer is going to be an inequalities. So let's see what we can do here. Of course, as usual, as just now when we do the question, right, we start off with the frictional force. So let's do the same here. Okay, so the particles has weight, which is mg, 0.6. So W equal to mg, right? So 0.6 times 10 equal to 6 Newton. So that is 6 Newton. Then we do resolutions. So this is going to be mg cos theta. And this way is going to be mg sine theta. Okay, so since we want to find out the frictional force, so we just do like this. Frictional force equal to mu r. So equal to 0.36. The r, right? The r is, okay, let's say I start off with formula first. Mu mg cos theta. The r is mg cos theta. So now I substitute 0.36. The mg is 6. The cos theta 25. So by doing so, we press calculator. We will get frictional force, which is equal to 1.958 Newton. 1.958 Newton. So that is the frictional force. Okay. So once you get the frictional force, then we have to understand the question in two situations. First of all, you see the question said the particle is in equilibrium. So we have to take it in this way. When the particle is in equilibrium, that means, let's say in physics we heard before, maybe Newton's first law of motion. I can mention that at this moment because you learn in AS physics, right? So in Newton's first law of motion, right, the object can be stationary, which remains stationary. And that is one type of equilibrium. Okay, one type of equilibrium is initially stationary and remain stationary. So that is one type of equilibrium. And the second type of equilibrium is the particle is already moving initially. And according to Newton's first law of motions, it remains moving with constant velocity or constant speed. Okay, so let's say I make myself easier. The question never say it is moving or not moving. So to make myself easier, I assume that the particle is initially not moving, which means stationary. So if the particle is stationary, so it will remain stationary because it's equilibrium here. As you can see, the forces is equilibrium. So the particles is going to remain stationary. Yeah, it's going to remain stationary. Yeah. So now I break it down into two situations. If the P is big enough, the particle is about to move up. If P is big enough, the particle is about to move up. So let's say it is about to move, but not moving yet. Remember, not moving yet. It's about to move up. We have to set this because when it is about to move up, then we know that the friction is opposing the wording that I said about to move up. Okay, is opposing that. That means it acts downward. Okay, let me write down. Okay, so I put it in case 1. Maximum value of P causes the particle to okay, maybe I put like this. The sentence sounds a bit weird. Okay, maximum value of P, the particle is about to move up. Okay, move up the slope. Okay, so we set this so that the frictional force is down the slope. Okay, so and because of that, what we have is, okay, let's see. I just draw a simple diagram at the side here. So this is the slope. The particles is here. The P act up with maximum value to make the particle to go up, going to go up. Okay, and because of that, the frictional force is acting downwards. The weight component is still acting downwards. It's always downwards, the weight component, mg sine theta. Okay, so the equilibrium is in this way. So forces acting upwards is equal to two of these forces that act downwards. That is the equilibrium that we can form. So in that case, we have P equal to mg sine theta plus frictional force. So we substitute with value. So the mg is 6, the theta is 25, the frictional force is 1.958. So we get 4.49. 4.49. This is the maximum value of P. So now let's look at the second case. Case 2. Case 2. We are going to look for the minimum value of P. So imagine that the force P that applied on the particle is very small until it is like not enough to hold the object, and the object is like about to move downwards, but haven't moved yet. If it start moving, it's not equilibrium already. So it's about to move downwards. So in that case, the frictional force, which opposes the motion, will act upward. So we have to set it in that way, because we want to set the direction of the frictional force. Okay, so minimum value of P, so that, okay, I write down, so that the particle is about to move down. In that case, frictional force is up the slope. So in this situation, let me draw out. If the particle is here and P is so small until not enough to hold it, so because of that, the particle is about to move downwards, and the frictional force, which always act opposing the motions, so which is these directions, and mg sine theta is always down the slope. This is the weight component. So in this situation, we can set up another equation. So we can take P plus frictional force equal to mg sine theta. So P plus 1.958 equal to 6 sine 25. So by doing so, we can get P. Okay, so we have to press calculator, and at the end, we get 0.578 Newton. So from here, we get two values. From case 1, what we get is the maximum value of P. So let's say I call it P max. From case 2, we get the minimum value of P. And let's say I call it P minimum. And let's see the question again. The question said, find the sets of possible values of P. So we just put it in set. They want inequalities. Okay, so maximum 4.49 we put on the right. Minimum 0.578. Okay, so that is the inequality, and this is set, right? So we just put it in set. The way to put it in set is P colon means such that, okay, P such that P is from 0.578 to 4.49. So as long as the P is in between of this value, the particle will remain stationary. Then we put the set notation. Okay, so settle for this one. So we have two questions now.